Hi, guys. Thank you for joining. This is Essence of Science, and today we're talking about if we have free will. I'm Amanda Armagost.
I'm Jimmy.
And I'm Dr. Abbasi for Essence. Amanda, is there a free will?
That's so tough. I think we have the illusion of free will, and I feel like we do have free will within a certain amount of parameters. Like you can do whatever you want within this box, kind of, but I don't know for sure if we do have free will or not.
Jimmy?
I would say no, but it still depends on how you define free will.
Yeah, how do you define free will?
You might think I choose to press the space button here. This is my free will, right? But in like a bigger perspective, maybe it's influenced by something, influenced by the podcast because we're talking about it. That forced me to do something out of ordinary, like pressing this button. So it's not a free will in some way, right?
I think that's determinism.
Yeah.
When like factors and things like that lead up to you making a decision.
Now, there is a huge concept in the philosophy about free will, and you can approach it from different directions, from theology, from philosophy independent from theology, but this is the essence of science. So not a theological or philosophical or life kind of things.
Okay.
So let's say, let me tell you though how I came to the free will concept, right? When I was a little kid and I was watching all these movies and so on, I think about telepathy and so on, I looked at the watch on the clock on the wall, and I tried really hard to make it stop. And I spent a lots of time and energy. The clock didn't stop. So the concept of time is very dependent on what we call free will, because it's all about causality, meaning that it's something that caused something that caused something that caused something. And we know in the physics, in the science, not theology, not philosophy, there is a so-called light cone. Are you familiar with the concept of light cone? Meaning that for anything to influence something else, the fastest you can move is speed of light. Like you smile at me, and with the speed of light, your face picture get transferred in my brain, and that starts a reaction, or you start cringing. Again, there is a speed. These are time dependent. So, for example, there are certain parts of the universe they can never influence us in any way, because the light of that or any electromagnetic wave from that area can never reach us. There is no causality between. So the so-called concept of light cone in the physics is that what area of the universe can we interact? And imagine that we are in one point in time here. There's a lots of places in the past that can influence subsequently and come to us today, influence us, our decision today. And from now on, there's a cone that going out, so it's like a diagonal line, and then we can influence certain part of universe with things that we do today, right now. But there are certain areas are far, Amanda is yawning already. Certain areas of the universe are way beyond our cone of influence or light cone. Now, having said that, that is about, like, imagine, like I just heard upstairs from Ross that NASA says there's a huge asteroid is coming toward the Earth. Have you guys heard of that?
No.
Yeah.
You heard about that?
Heard about that, yeah.
Yeah. So that asteroid was 1 million years ago still there somewhere, right? And had a trajectory. So if a piece of dust, just a grain of dust, 1 million years ago hit that asteroid would be now somewhere else.
Yeah.
So that little bit of a dust that hit the asteroid or didn't 1 million years ago has influence if that asteroid is going to hit us and kill us all or not.
Is there really an asteroid coming? Like,
That's what I hear.
It really is.
So yeah, it might be that we are in the end time. So let's use it to good extent. So now imagine, obviously the asteroid doesn't have a mind, right?
Yeah.
But we do, right? So, but what is it? What makes us believe? That's a question for you. What is it? What makes us believe? You said about illusion of free will. Quite honestly, I don't know the answer to that, if you have free will or not. But I'm going to talk about the science, what science and physics thinks if there is a free will or not. So what makes you believe, or maybe that's a wrong answer to you, because you think even stones have a personality and,
I don't know if I think they have a personality.
no, not personality, but you think that even inanimate object, they have a soul or soul-like
I
things?
kind of feel like it sometimes, yeah.
Yeah. So,
But I feel like we have an illusion of free will. I guess it kind of depends on where you're born and where you're living. Like,
mhm.
I think government gives us a lot of illusion of free will because in the US, we're known to be free. We have like all these rights, freedom of speech, freedom of this and that. But do you really have free speech? You know what I mean? If you can get arrested for saying certain things. Do you-
You're going completely
No,
different
but
direction.
like I can choose whatever job I
Yeah,
want, and
yeah.
that's free will.
Yeah.
Or I can choose to be unhoused, and that's also free
Yeah.
will.
So let's go back to my childhood, where I said I understood the concept of time and I cannot stop the time by free will or willpower or anything. The second thing that I noticed that I was my neighbor next to me, we were good friends, and it was a wall in our roof that I could go over the roof to their house and then we could play and so on. Someday I realized the only way for me to get to them is climb over that wall. So it doesn't matter how much I want or my will that I want to go through the wall, it probably won't work. So what I considered as a free will is was so much limited to physical reality. So simple words, I cannot go through the wall. I can, yes, I have a free will from here to go to the lobby, but I cannot go directly. I have to follow the
Free will
physical
is constraint. Either is.
And I mean,
this
couldn't you smash the wall and go through it? Technically.
Oh,
yeah.
Technically, you can, yeah.
But
Yeah.
then there's consequences to your actions.
Well, and there are some walls. Doesn't matter how much I want. I cannot.
Even if you had a bulldozer or a wrecking ball.
Yeah. Then we are getting somewhere, you know. So, but the concept's still the same. I have free will within the physical reality.
Mm-hmm.
If I more hurdle physical reality is there, it takes me more energy. We're talking about the physics now, science. It takes more energy. I have to explode a. If I want to go through a mountain, I have to, spend billions and billions of dollars, explode a hole in the whole mountain. So within constraint of the physical reality, so at best, my free will is constrained by physical reality, and if physical reality is not conductive, it takes more energy to overcome the hurdle to make my free will possible, right?
You either climb through it or you smash through it, or you cannot accomplish your
Yeah.
will.
So that makes it a very clear case. Free will is under or is subservient to physical reality. You cannot fly, at least not by flapping your wing. Well, if you have a lot of money, you can buy one of those machines that you put on your back and you fly and so on, but then it costs $60,000. $60,000 means a lots of energy. Money is energy. That's what we need to understand, okay?
And destruction.
And time. Yeah.
And irreversible destruction, like the mountain example. If you use dynamite to blow up the mountain so you can go through it,
Mm-hmm.
you can't get that mountain back.
So we can agree that free will is limited at best. So, but in 17th and 18th century, philosophers went another way. They understood the concept of motion, like Newton said that, if you're
An object in motion stays in motion.
yeah, 3 laws of motion, and meaning that takes a simplified universe, that it's made of a pool table with balls. Now, generally, we have the concept that we have balls in the middle, and we start hitting them with a black ball, and then they spread out. And then I think everybody can understand that if you have the balls, you hit them and they disperse. If you take a video and reverse that we all understand there's something wrong with that picture, that literally if the all balls comes together and the black ball goes back, that is something not right. That's reversed.
Yeah.
Now, but forget about that part. Imagine that just 2 balls that hit each other. The first ball hit the other ball, and the other ball moves, if it's the same mass, with the same speed. We disregard the friction and so on. If you reverse that, there is no way you can know which one hit which one, or which one was the cause, which one was effect. Yep. So cause and effect can be literally in the physical reality, it can be reversed.
If it's if there's no friction.
Yes, if there's no friction, but even if there's friction, even with friction, because friction is some of the energy getting transferred to other atoms. That's all what it is. At the end of the day, everything.
If there's friction, if you reverse it, you will see a ball slowly hit another ball. The other ball is fastly going away. That's impossible.
Yes, no, well.
Or you'll see the speed changing if there's friction.
Really?
Yeah, let me.
If there's friction, the ball that got hit would slow down eventually.
Well, but let's find out. Let's go further deeper. Okay? What is temperature? It's all about thermodynamics. What's temperature?
The movement of
the speed of the motion of atoms.
Yeah.
That's what temperature is, right?
The faster, the hotter.
So what that means that, if you have certain temperature, that's how they found actually atom exists. Atom moves in certain speed, and each of them is like a billiard, like a pool ball. And if the temperature is high, they move faster. If the temperature is colder, they move slower. Now, imagine one atom hits 2 atoms instead of 1 atom, and the energy gets dispersed in 2 atoms, not 1 atom. Things slowing down is exactly that. What that means is that while the billiard pool is moving, some of the motion goes to the other ball, but a small fraction of it goes to everything else on the table and so on. So in the bigger picture, in the physical reality, I'm not talking about the billiard pool, if you reverse that, you still cannot say. They have done all those studies, and the physical basic of it, there is no way that the motion or 2 element or atom hitting each other, you can know which one was cause, which was one reality. The only thing that makes sense in the physical reality is the so-called entropy. Are you familiar with entropy, Amanda? Do you know what that is?
Tell me.
It is from order becoming disorder, like a deck of cards. They are all nicely sorted, like from ace to queen in the red, and then another one. They're sorted, all sorted. You throw it up, they come back down, you put them together, and then all of a sudden the order is not the same. It's from order to disorder. And entropy is the only way that we can make sense of time, because there is always 100%, always goes from order to disorder. And that is what the thing is, at the beginning, all the balls of energy is in the ball, but then it gets dispersed. At every single level, when you look back, it's reversible. What that means, and that is lots of theoretician, mathematician, physicists believe for a long time, still they believe. You have the exact location and speed of every atom in the universe. From that moment, the entire future and past is predetermined, and it makes no sense, no different in what direction you're going. You can predict the entire future by knowing exact location of every atom and mass and speed of every atom in the universe, and you have entire future, meaning that
Then you have no free will.
and there is no free will. Based on that theory, there's absolutely no free will. Well, let me go to macroscopic level. Like, you think you wanted to push that thing or not push it, right?
Yep.
Whereas the physical reality says, my voice, the energy of my voice, and my words and information you gathered from me brought you here.
Yeah.
And then we started a conversation. And then that conversation changed practically the constellation of your electromagnetic activities in your brain, where you came to that point that push it or not push it. But all of that went into the direction, the gravity of the electromagnetic activities in your brain made you push or not push it. So it's all predetermined. And the fact that there are so many different options gives us the illusion that there is a free will or not. And that, for a long time, before quantum physics, that was our understanding, that practically it was an almost nihilistic thing, that nothing really matters. Everything is predetermined. It's almost like theology, that God knows everything that will happen has already happened. Literally, the philosopher and the physicists were saying, time is an illusion. Everything that can happen is already predetermined, and so on. And only thing that it makes sense here is the increase in the entropy that gives us the illusion of time. Now, and then Heisenberg and Schrodinger happened. And again, this is the essence of science. Do you know who they are? Have you heard of Schrodinger cat?
The cat, yeah.
If
the cat is inside the box, is it dead or is it alive?
Yeah, so can you explain that more than that? No? So what do you know about the Schrodinger cat?
I think is that before you actually look into it, you never know if the cat live or dies or exists or not.
Mm-hmm.
One of them.
Yeah.
So it's in a state of uncertainty.
Mm-hmm. The father of quantum physics was Max Planck. And Max Planck did something, what we call it, these are related, so bear with me. Until then, physics would work on everything, and some idiots thought there's nothing new in physics that we can discover. We just have to have better measurements. As a matter of fact, the main physicist was thinking end of the last 1890s that everything we discover, 1890s, they thought everything that need to be known is already known.
That's how I feel about the periodic table.
Yeah.
The way you feel about that.
Yeah.
Yeah, so they all go to philosophy.
Yeah. And so, and then and that there was a problem in physics. See, it was something that we call black body radiation, meaning that you take a black body, a body that absorbs all the light and then emit it. It doesn't reflect anything. It just absorbs and emit it. Do you know what's a perfect black body? What's a perfect black body? That all the light that comes on it get absorbed. Nothing gets reflected.
It's a black hole.
No. Star, sun is the perfect black body. Does it make sense?
Because it's too light.
No, it is because every light that falls on star like sun get absorbed. The light that you see is not the light that fall on it. It absorbs it, change it, and reflect it back. It doesn't just reflect it back. It just absorbs all the light that falls on it because it's so dense that nothing really comes back. Yeah. So, but because we studied the sun, we knew the light that gets sent from a black body or any object, like your body is already having ultra infrared light reflecting, has something to do with their temperature. As a matter of fact, whole science of spectroscopy existed because of that. That the wavelengths of the electromagnetic wave that comes from an object tells about its temperature. And it worked until you get to the ultraviolet. And then, based on their calculation, everything that got in that direction came into ultraviolet region, their energy should go to infinity. They called it ultraviolet catastrophe. What that means is that their calculation didn't make sense. And Max Planck said, we know experiment doesn't agree with that. So we never see that when you heat up something, all of a sudden the energy go to infinity. That's not what the case is. But why does our formula predict that? It works up to that point. Why doesn't it work afterward? And then he did a mathematical trick. That mathematical trick was saying that the steps that energy increase is not indefinite, but it comes in so-called quanta, in small steps. Like it is not like a smooth thing that go up the in a mountain or something, but it is like a staircase. There's only certain amount. Once he put that in, everything made sense. That the energy is not has many infinite steps. It comes in certain so-called quanta or steps, levels. You know what was interesting? Max Planck, who made that mathematical trick, did not believe that that's really what's happening. He said, this is just a mathematical trick for us to correct the formula. I don't really believe that's happening. And it has happened so many different times with many different other, the scientists like Einstein found out that for the universe to stay static, he needs to add some constant. They called it vacuum constant, so that the formula makes sense. And he said that doesn't exist, but I'm just adding it. And now we know that that constant is the most important work of Einstein, that vacuum has a vacuum energy. So with Schrödinger cat was something similar. Schrödinger found out this fact that nothing is real until you look at it. It is fact, but he said he didn't believe in that. The Schrödinger cat actually was Schrödinger making fun of his own theory, that how ridiculous that is, that you have a one element that you don't know, and that is the quantum theory, that you have a status of let's say an electron. Is it a wave or is it a particle? Is it here or is it here?
You don't know until you see it.
You don't know until you look at it. Until you look at it. And Einstein used to say about that, I want to believe that moon exists even if I don't look at that, or and so on and so forth. So the idea, our brain is not made to understand that. And then a group of physicists, they call them Copenhagen interpretation, because mostly it was Max Bohr and in Copenhagen. The Copenhagen interpretations is that nothing is real until you look at it physically, okay? Or and practically, Schrödinger says, imagine you have a small little radioactive substance. It can decay or not decay. What that means, it is doing both. It's decaying and it's not decaying at the same time. But if that's the case, imagine if it decays, you have a Geiger, the measurement device where it measures the radioactivity, and if every time it decays and gives the radioactive energy, it makes a click, and that click can activate a device that open up a bottle of poison, and that kills the cat. So meaning that uncertainty at the molecular level can cause a macroscopic event, which then is the cat alive or dead? That depending on if that radioactive substance decays or not decays. If that is uncertain, meaning we don't know until we look, then the cat is as well. And he thought how ridiculous that is, how counterintuitive that is. Now, imagine going from that uncertain something decays or not decays to cat being alive or dead, to all the small processes in your brain, to your decision to click or not click, meaning that we don't really know until we look at that. And that sort of, for lots of people, they thought that will give science a way out to say, okay, free will does exist. Especially, it gets actually important. Let's see if you guys understand this joke. The other guy behind Heisenberg was Schrodinger. Schrodinger wrote the equation, and Heisenberg, really, they both worked on this uncertainty theory, that you can know the direction, mass, or speed of a particle level. You cannot know both. Direction and mass are the same, but no, and so on. But either way, the joke is Heisenberg and Schrodinger are on a country road, and all of a sudden a police officer stopped them and asked them, do you know how fast you were going? Schrodinger says, no, but I know where I am. And then the Heisenberg, and then police officer says, you were going 70 miles an hour. And then Schrodinger says, God damn it, now we are lost. You get the joke? No, it's hard to get. So police officers ask them, do you know how fast you were going? And they answer, no, but we know where we are. And then when the police officer tells them how fast they were going, no, they don't know where they are.
So they can only know one?
That is a physical reality. This is not a joke. This is so counterintuitive. This is so maddening. If you look at the reality of that, I mean, you can take a, I did actually one of my TikTok, I did that experiment, that this is something you can see with your own eyes. You can, in your kitchen, you can experiment that this is a physical reality, that you cannot know position and speed of anything. Once you know more about the actual location, in macroscopic world, it doesn't really matter. But once you get to the very tiny atom and so on, more you know about the location of something, less you know about its momentum and speed. And let me tell you how you can do it in your kitchen. If you now get one of those, you need 3 filter, polarizing filter. If you go to movie theater, take 2 of those glasses, and then you need 3 of those. Now each of them will come with 2, and they are usually the 90-degree rotated. So meaning that one eye sees something, the other eye sees something else. That's how you see 3D. Now you get one of them, you put light, you look at the light. Obviously, that one polarize the light in certain direction. You put the other one in the same direction. Then you don't notice any difference whatsoever, because light got polarized in one, and then the other one, let's say the same direction of the light, it did it through, and then you start rotating one of them 90 degrees, and then it goes dark. Once you make them 90 degrees to each other, they get all filtered and it almost goes dark. Now, you have these two filters now 90 degrees to each other, meaning that they filter everything and they go dark. And then you put the third one. You put the third one between. Everything in your body says when you put the third one, it gets even darker. Because you have two polarizing, filters that practically absorb everything. And the third one make even less light coming through.
But it's in the middle.
Yes, it is in the middle, yes. But it doesn't matter where it is. But the thing is that you have two that are very perpendicular to each other, and the third one, this is a different or random angle to them, right? So your nature want to say, your brain want to say that the half of the light or whatever part of the light get absorbed in the one that let you go only in this direction, right? And the other one only let go this way, so anything that comes here get blocked. So, and you put the third one, all of a sudden it becomes brighter.
Right.
Why? You don't understand that until you really agree that the light has a mind of its own. That almost like light is like Amanda, hit the first one, and say, I don't like that, I want to move around, and it's a probabilistic. Literally, you can calculate by putting a third one, you increase the amount of the light. Or you have a laser. I did the experiment in my office. You put the laser on the wall. Once you put two blades or two razors close, that you make it smaller when the light is passing through. Actually, the light there on the wall spreads out as if the light says, if you narrow the area that I'm passing through, that you confine me to exact location, my momentum will change that much that I'm going to spread out on the wall. This is, if you understand physics, that is closest you come to agree with you, Amanda, that every light, every particle has its own mind, that has a soul, and so on and so forth. That truly, maybe there is something in that. We are not the only people who have a mind or a will and something, because literally they behave like a moody teenage, the light particle, they behave like a moody thing. If you are not going to let me go this way, I'm going to go that way, and I'm just going to defy you, and so on and so forth. And that becomes a physical reality. That's how everything really works. It's mind-boggling how that works. But coming back to that, so quantum physics gave us a way that maybe there is free will. Except, it's getting complicated now, that when you run the statistic, even that choice is an illusion, because statistics,
right?
huh?
That's 100%.
What do you mean?
Because 100% of the time you add in the third layer of the
No,
it's gonna be brighter.
Yeah, 100% of the time it gets brighter.
So the light doesn't have a free will of, oh, I want to get dark this time.
Yeah.
So they do not have a free will.
Yeah,
that's fixed.
Yes, you get it. You absolutely get it. That statistically is predetermined, meaning that even though those light particles, as a matter of fact, they did those studies absolutely crazy. There is so-called, again, we are talking about this in this way because this is the essence of science, not essence of something else. Okay, so there is so-called famous double slit experiment, where you send the light through one slit, it behaves some way, but when you send it through two slits, they interfere with each other. Light is a wave, like throwing two stones in a pond, and those waves interfere with each other. The interference becomes either constructive or destructive, and then you have those light patterns. That is how all we know about the waves and so on. Now, the problem was they started sending electron through double slit. And then they saw when you send this electron through double slit, they behave like a wave. Say, wait. Electron is a particle. How does it do it that way? How does it go interfere with each other? Oh, maybe when we are sending it, when they hit the wall of that slit, they create something else. Then they started sending those electrons one by one, literally. They send one electrode, wait, once it hits the wall behind the double slit, they send another one, then they send another one, then send another one. And there's still one single electrode create that wave behavior, the interference and so on, one single electrode. And then they did something interesting. They put a detector that detects which hole the electron goes through, because electron can go through one or another, or hit the thing and not go through any of them. When start looking at the electron behaves like a particle, made like a one line. But when they didn't look and that just looked at the wall, it behaved like a wave. It is like I behaved again like a teenage girl. If you look at me, I'm going to do something, but if you don't look at me, I'm going to behave different way. And lo and behold, they did a fantastic test that they didn't look at it until the electron passed the double slit. Then for a fraction of a second, they looked at it. And then what they notice is something that breaks all barriers. It's amazing. When you imagine this is the double slit, the electron already has passed, already has decided if it's going to be a particle or a wave. But once it passes it, afterward, if you look at it, the electron goes back in time and behave as if it was particle or wave. So we have no understanding how it works. So coming back to the conclusion, based on our current understanding of quantum physics, even though lots of people say that that predeterministic Newtonian view of free will is complete nonsense, quantum physics gave it a path for reality to exist with a free will. But when you run the mathematics of it, it is, at the end of the day, quantum physics as deterministic as Newtonian view. So enjoy what you consider a free will. It might all be an illusion.
Might be decided already.
So all your decision and so on might be already decided. But I think what's amazing though is that that the reality is very different than what the true reality is very different than what we consider reality. And for you, Amanda, so even an electron might have a will, if you want that, really take it that way, because in the contrary to us, an electron can go back in time and correct the path that he has been taking, and so on. So I hope this wasn't too dry for our conversation.
Thank you guys for watching. This was Essence of Science, and we talked about free will. I'm Amanda Armagoss.
Jimmy.
And I'm Dr. Abbasi for Essence.
Have a good day.